Okay, this is just a quick recap, ready for the next topic we're going to start. So we're now going to look at 2D kinematics. So that just means we're going to combine suvat and vectors. So a quick recap on how to do these two things. So let's start with suvat. Just remember there's 5 equations that you get given, so you don't have to memorize them, but we can only use suvat if is constant. So if we have constant acceleration. If A is variable, so that means A changes, then we don't use suvat, we use dVA. And that's when we have displacement plus the acceleration. And to go down, we differentiate. To go up, we integrate. Okay, we'll do a bit of that with vectors as well. Okay, suvat, you've got your 5 equations, which again, I'll just stick down here, test that I've got them all. So S is a half t times u plus v. S is ut plus half t squared. S is vt minus half t squared. And v squared is u squared plus 2as. Yeah, remember they all just come from different things. So equation of a straight line, trapezium, rectangle plus triangle, rectangle take equal triangle, and that one just have to do a bit of rearranging. Okay, there's some key facts that might help us. So remember, we always choose the direction for positive, so up or down, doesn't matter. If something's free falling, then the acceleration is gravity going down. It's only if it's free falling, so there's no other forces. We have that if the speed is at its maximum speed, then A is 0, so that means maximum or even minimum speed or velocity. We have that if v is 0, then that means there's no velocity, so it's instantaneously at rest. So that means it's not moving in that specific time. And if s is 0, then that means it's returned to where it started. Yeah, not that something can be instantaneously at rest and not moving, however, it can be accelerating. Yeah, otherwise, if v equals 0 always meant A equals 0, then nothing would ever stop moving, because you have to have some acceleration to get you to start moving. Okay, then we can combine that a little bit with vectors at the minute in terms of distance is magnitude, and I'm going to use this notation, the magnitude of displacement. And speed is the magnitude of velocity. Okay, so we know that as well. And we know to get the average speed, then we can just do the total distance divided by the time, the total distance traveled. To get the average velocity, we can do the total displacement traveled divided by the total time. Okay. To link that a little bit with what else we know in mechanics. So sometimes we're looking for these 5 things. However, we might also have to use these 3 things as well. Look, F equals ma, because that bit there could be the same as that one. So if you're doing these, and A is one of the things you're missing, and another one's missing, check, can you use the equation of motion, F equals ma. Okay, and last one, vectors. Okay, so you know that you can write vector, so it's like 1, minus 2, 3. That can be written as 1i minus 2j's plus 3k's. Yeah, and I just means up, 1 up, j means 1 across, and k would mean 1 out. So coming towards me. Okay, now we know to get the magnitude of a vector, we square them all, add them together, square root. And if we wanted to get the distance between two vectors, or let's do displacement first. So from A to B, we do O to B, take away O to A, where O is just the origin. So A to B, O to B, take away O to A. And in fact, that works with whichever other vector we have. So if I had C, I could do C to B, take away C to A, and that will get me A to B, as long as that first point is the same. Okay, now if we just focus a little bit more on 2D vectors, because that's what we're going to do next, 2D kinematics. So if I have a vector, let's say 2, 5, then I can get, so that means 2 along and 5 up. Then I can get the magnitude, so this thing here, by doing the Pythagoras, just like we said, 2 squared out of 5 squared, so that will give me this. And if I want the angles that I can make with the vectors I and j, I could use just SOHCAHTOA, or I also told you this formula where to get an angle, and let's just do I angle, so that would be this thing here. To get that, it's inverse cos, or cos, you put the I component on the top, so the I component is 2, divide by the magnitude. And equally, if you wanted the angle mix with j, so that would be this here, the angle mix with j would be cos j component, which is 5, divided by the magnitude. Yeah, and this formula just helps you in 3D, so that's why I told you this formula. Yeah, but equally, they could give you the magnitude and the angle. So they could say there's a vector, magnitude, so let's use the notation, magnitude of the vector is, let's say, 7, and they could give you an angle it makes. So they could say the angle to the horizontal is 40 degrees, and they might want you to find the vector. So the easiest way to do this is to draw it. So there's my horizontal, there's about an angle of 40, and the magnitude 7. So we've done lots more of this in mechanics now. So to get the adjacent bit, this bit here, well, that's going to be adjacent, so it's 7 cos 40, and to get the opposite, 7 sine 40. Yeah, and all the skills we're going to need in the next bit. And a little bit about parallel as well, but I'll recap that in the lesson. But very quickly, 2 vectors are parallel if scale multiples. So scalar just means a number, not a vector. So for example, 5 and 10 and 10 and 15 are not scale parallel, they're not scale multiples, because 5 times 2 is 10, but 10 times 2 is 20. So 5, 10 and 10, 20, these 2 vectors here are parallel. But these 2 aren't. If it says something's parallel to the I vector or the x-axis, then that means it will be something times 1, 0. And equally, if something's parallel to the j vector, then that's something 1. And they might also call that east, might call that north. If it was west, that'll be -1. If that was south, that'll be -1. If it was northeast, then there'll be 1, 1, 1 across, 1 up, etc. But I'll talk more about that within the lessons.